All right, let's get right into it. We're about to explore a technology that could completely change one of the most common appliances in your home. And it all comes down to the invisible, powerful force of magnets. You know that constant low hum you hear in your kitchen? Yeah, that one. It's coming from a machine that's basically running on technology that's over a century old. And, well, it's got a secret. A pretty big, dirty secret that's been hiding in plain sight this whole time. For years, the big push has been all about making our fridges and ACs more efficient, right? But what if we've been focused on the wrong problem? What if the real villain here isn't the cold itself, but the chemicals we use to create it? We're talking about gases that have a staggering potential to warm our planet. So it really makes you wonder, is there a better way to do this? So before we get to the amazing new solution, we have to really understand just how big of a problem we're dealing with. Let's pull back the curtain on our refrigerator's dirty secret. It's a system called the vapor compression cycle. Basically, it squishes and then expands a chemical to move heat from inside a box to the outside. And look, it works. It's been reliable for 100 years. But because it's been the only game in town for so long, the industry got, well, kind of complacent. They've been ignoring some pretty major downsides, like how much energy it hogs and the nasty chemicals it relies on. And this is where it gets wild. You take all the refrigerators, all the air conditioners in the world, and they add up to a whopping 20% of all electricity used on the entire planet. That is a gigantic energy footprint for something we barely even think about most of the time. But the electricity use isn't even the whole story. Not even close. The real danger is what happens when those refrigerant chemicals leak out. These things, mostly what we call HFCs, are super potent greenhouse gases. So potent, in fact, that they're responsible for almost 8% of all global greenhouse gas emissions. That's huge. Okay, so clearly we need a new plan. Which brings us to the really exciting part, a totally different approach. What if we could cool things down with just magnets? The core science here is something called the magnetocaloric effect. It sounds complicated, but the idea is actually pretty intuitive. Imagine you have a special material. When you bring a strong magnet near it, it forces all the tiny atoms inside to snap to attention, all lined up. When they do that, they release a burst of heat. Then, when you pull the magnet away, the atoms all relax, and to do that, they have to suck in energy from their surroundings, which makes the material get really, really cold. And this isn't some sci-fi thing that was just invented. The basic effect was actually spotted way back in 1881. For a long time, it was just a neat trick for scientists trying to get things incredibly cold in a lab. The very first magnetic fridge in 1933 was this huge, clunky thing, but it worked. It got things down to just a tiny bit above absolute zero, which was a game changer. The real moment for us, though, was in 1997. That's when we got the first prototype that could work at room temperature, and that's what opened the door for the stuff we're finally seeing today. So let's walk through it one more time. Super simple. Step 1. You've got your special material just sitting there. Step 2, you hit it with a magnetic field, all the atoms line up, and boom, it gets hot. You then get that heat out of there. Step 3, you take the magnetic field away. The atoms all go back to their lazy, random state, and in the process, they suck up a ton of heat, making the material colder than it was when you started. That's the whole cycle. All right, so that's the basic physics. Pretty neat, right? But how do you actually turn that little trick into a machine that keeps your food fresh? Well, that's where the magnetic cooling cycle comes in. And what's so elegant about this is how it mirrors the old way of doing things. In your current fridge, you compress a gas to make it hot. Here, you magnetize a solid. In your old fridge, you let the gas expand to make it cold. Here, you demagnetize the solid. See? It's the same fundamental idea, just done with magnets and metal instead of compressors and chemicals. The absolute heart of this new kind of machine is a component called the active magnetic regenerator, or AMR for short. Now, all a regenerator does is move heat around really efficiently. In this case, the AMR is basically a special chamber that's just packed with that magic magnetocaloric material. It's designed to shuttle heat in and out at lightning speed as that magnetic field flips on and off. Okay, enough with the theory. Let's see what this stuff actually looks like in the real world. Time to meet the prototypes and the pioneers who are making it all happen. So, take a look at this. This little comb-shaped block of metal, that is the refrigerant. It's a solid alloy, no gas needed. It's made of some fancy elements, sure, but the main thing is this solid chunk does the job of all those harmful gases. And that comb shape, That's not just for looks. It's designed to have a massive surface area, so a fluid, like water, can flow through it and grab or dump heat super fast. And here we have the whole shebang. This is a real working prototype from a lab. You can see all the pieces. That round part is a super clever magnet setup called a Hallbach array. It basically creates a super strong magnetic field on the inside and almost nothing on the outside. Then you've got the chamber where that solid refrigerant sits and the pumps to move the fluid around. This isn't a drawing, folks. It's a real machine that actually works. And make no mistake, there is a global race happening right now to get this technology to market. Over in the US, you have the Ames National Laboratory cooking up brand new materials to make it even better. In Europe, startups are moving fast. A company called magnetocaloric just showed off a really slick beverage cooler just this year for bars and restaurants. And another one, Magnetharm, has already done it. You can actually buy one of their commercial units today. So yeah, this technology is officially out of the lab and in the real world. And I love this quote from Kai Steinecke because it really hits the nail on the head. He points out that refrigeration tech has been stuck for centuries, guzzling energy and using nasty gases. But this new magnetic cooling, it's not just a tiny improvement. The claim is that it's up to 30% more energy efficient. That's not an upgrade, that's a revolution. So the big takeaway here is that this is real. It's happening. But what does the future of cool actually look like? What's standing in the way of this being in every kitchen? Okay, let's be realistic for a second. It's not all smooth sailing. There are definitely some big hurdles. For one, the special materials are still pretty expensive, and figuring out how to mass produce these things cheaply is a tough engineering problem. Not to mention, you're going up against an industry that's had a 100-year head start. And maybe the biggest hurdle? The powerful magnets you need are the exact same ones everyone wants for electric cars, so there's a lot of competition. But the payoff for overcoming those challenges is just massive. We're talking about a cooling system that's totally safe, no flammable or toxic gases. It's sustainable with zero direct global warming impact. It could be up to 30% more efficient. And maybe my favorite part, it's quiet. I mean, can you imagine a refrigerator that doesn't make that constant humming noise? Total silence? And that really brings us to the final thought. A whole new tech race is on. The goal? To completely reinvent a 100-year-old industry, to replace the noisy, polluting machines we all have in our homes with something clean, efficient, and powered by the silent force of magnetism. So the question isn't, is it possible anymore? The real question is, how soon will one of these be in your kitchen?